4.4 is binomial probability. We start with something called a binomial experiment, or sometimes it's called a Bernoulli trial, named after the mathematician that found it. Okay. Number one, the same experiment is repeated a number of times, like drawing a card, put it back, draw a card, put it back, draw a card, put it back. Same thing over and over again. There are two possible outcomes, success and failure. Either you drew an ace or you didn't draw an ace. Trials are independent, so the probability of success is the same for each trial. If probability of flipping a coin and it shows heads up is 50%, you do that over and over and over and over and over again, it's going to be 50% every single time. All right, so we got a formula for the probability of X successes out of N trials. What that's going to be is N choose X, that's going to be a combination, times the probability to the xth power times the probability that it doesn't happen to the n minus x power. And that formula looks really confusing because of all the n's and the x's. It's really not once you get into the numbers. Okay, so let's say I want 3 successes out of 7 trials. That would be 7 choose 3. And then let's say the probability is 1/4. So it'd be 1/4 to the 3rd. And then the probability that it doesn't happen would be 3/4 to the 7th. No, not the 7th. 4th. Thank you. Those two exponents, 3 and 4, have to add up to the big number 7. And every one of them is going to be some variation of that in this lesson. Number 1, a single 6-sided die is rolled 10 times. Find the probability of rolling a 4 exactly 3 times. So what you're going to want to do is make sure you know the probability. The probability of rolling a 4 on a single 6-sided die is 1 out of 6. That implies the probability of not doing that is 5 out of 6. That's kind of an important thing. So notice we've got 10 trials. We're rolling the thing 10 times. And so it's going to be 10 choose. We want exactly 3 times, so it's going to be 10 choose 3. That means we're going to roll a 4 3 times. So that probability of 1/6 is going to happen 3 times. The other thing must happen 7 times. So that's it. You should be able to just type that in on a calculator. Hopefully. Get about 0.1550. I like 4 decimals. Look like that. Part B, find the probability of rolling a 4 at least 9 times. And so here's where it's going to get a little bit tricky, I suppose. When they say at least 9 times, you want to be hyperliteral. At least 9 literally means 9 or 10. I like to rewrite problems using the words and or because it helps me to see. I know in this case, or means plus. So I'm going to have 2 different applications of this formula. Once I'll go through with a 9, and then I'll go through with a 10. So for the 9, I'm going to say 10 choose 9 times 1/6 to the 9th times 5/6 to the 1st. And then I got to do the same thing with a 10. So second time through, I'm going to go 10 choose 10 times 1/6 to the 10th times 5/6 to the 0. And 5/6 to the 0 is 1, and so if you know what you're doing, you're probably going to leave that out of your calculations. 5/6 to the 0 power is just 1. 10 choose 10, you're going to have that 4 all 10 of the time, so you can't really mix that up or shuffle that up at all. So remember the E on a calculator means times 10 to the, so move the decimal left 7 times. We've got 1, 2, 3, 4, 5, 6. Where's that 7? Move it left 7 times, so you'd have 6 zeros, and then 8, 2, 6, 9. But maybe we should have just plugged all of it in anyway. We had 10, choose 10 times 1/6 to the 10th. So 6 zeros, 165. So we've got those two probabilities, add those together. Eight, 4, 3, 4. Or 8.4 times 10 to the negative 7th. Number 2, a recent survey found that 59% of college students attend more than one institution during their college career. Suppose a sample of 6 students is chosen, assuming that each student's college attendance pattern is independent of the others. Find the probability of each of the following. Exactly 3 of the 6 students attend more than one institution. All right. So notice that's your probability right there, 59%. So 59% that do whatever they're talking about would imply that 41% do not do what they're talking about. This is a binomial problem. All right, so we've got 6 students, that's in, and we want exactly 3. So we're going to say 6, choose 3 times 0.59. And the way I remember it is you want 3 of them to do whatever the 59% is saying. And then that means there must be another 3 doing the 41%. Two, 8, 3, 1. We get about 0.2831. Okay. Part B says none of the students attend more than one institution. So that means x equals 0. All the other numbers are the same, the 59%, the 41%, but this time we want x equals 0. So we're doing 6, choose 0, times 0.59 to the 0, 0.41 to the 6. Now again, if you know how some of this stuff works, 6 choose 0 is going to be 1, and 0.59 to the 0 is going to be 1. So you may not even need to type that in. You can just type in 0.41 to the 6th power. Should get you where you need to go, 0.0048. Number 3, find the probability of getting exactly 7 heads in 8 tosses of a fair coin. So x is 7, n is 8. 7 out of 8 are going to be heads up. But what's missing is the probability of just doing it once. Coin flip, probability of heads up is 50%, 1/2, 0.5. Usually I like decimals better, but whichever's easier. And so exactly 7 means we don't have to do any funny business. 8 choose 7, and it's 0.5, and we want 7 of them. So think about the failure. If it's not heads, then it must be tails. What's the probability of not heads, I guess? Also 0.5, and I want 1 of them. So there's 7 heads. Think about what that means. Basically, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 tosses, and you got to shuffle 7 of them are heads, and 1 of them is tails. So what this does is it shuffles them and says, well, I don't know which 7 of them are heads, so we're going to shuffle them. And that's what the combination part is doing. So shuffle those results, and then 7 of them are heads up, and 1 of them is tails up. 0.03125. Sometimes the answer will turn into a nice fraction. This one might be that that time, 1 over 32. I like decimals better, but sometimes fractions are nice. Number 4, the FTC monitors pricing accuracy to ensure that consumers are charged the correct price at the checkout. According to the FTC, 29% of stores that use checkout scanners do not accurately charge customers. If you shop at 3 stores that use checkout scanners, what is the probability that you'll be incorrectly charged in at least 1 store? So you have to kind of pay attention to the language here. This says 29%, so that's going to be our p-value. And it says 29% do not accurately charge customers. So when I see incorrectly charged, that's the same thing. Do not accurately charge customers, incorrectly charge customers. All right, so that's what we're looking at. But let's see. When you see language like this, at least 1 store, sometimes you need to be hyper literal about what that means. At least 1. At least 1. Okay, think about what that means. At least 1 means 1 or 2 or 3, right? At least 1. 3 stores, at least 1, that's 1 or 2 or 3. So we want to do 3 different iterations of that formula. We've got 3 stores, so that's your n number, and we're going to use x equals 1. 3, choose 1, and then that means we're going to have 1 of the 0.29s. And what? 1 minus 0.29 is 0.71. So that'd be 2 that I guess do charge accurately there. And so what the 3 choose 1 does is it just shuffles up. Do we want the first one to be inaccurate, or the middle one, or the third one? Or means plus. And now we're going to go with 2. So 3 choose 2 of them to be inaccurate. That means 2 of them are going to be 0.29s, and 1 of them is going to be 0.71. Or means plus. 3 of them, 3 choose 3, and that means 3 of them are 0.29s, and 0 of them are 0.71s. So I'm not totally sure if we can type all this in at once. You can try it if you want to, or you can split it if you want to. Right. Let's see if we can just type it all in. Plus. A lot going on there. 0.6421. Okay, that looks right. Type it all in, 0.6421. That's the probability that it happens in at least one store. Now, sometimes you can find a more efficient way of doing it. Okay? Can anybody think of a different way of doing this problem instead of what I did? Think about what at least one means. At least one means 1 or 2 or 3, but it could also mean, anybody? What? Not 0. All right, so we could do this problem in a different way and say 1 minus the probability that 0 of them charge incorrectly. Or 1 minus, and then do the problem with x equals 0. So 3 choose 0, 0.29 to the 0, 0.71 to the third. Should be the same answer. 1 minus 3 choose 0, 0.29 to the 0, oops, 0.71 to the third. Same thing. Same thing. So, let that be a lesson to you. Sometimes you can find it directly. Sometimes you can find it indirectly. We talked about that in one of the previous sections. Find it whichever way makes the most sense to you. Part B, if you shop at 3 stores that use checkout scanners, what's the probability you'll be incorrectly charged in at most one store? So again, you want to look at the language and be hyperliteral. At most means 0 or 1. 0 or 1. And so you've got 3 choose 0 times 0.29 to the 0, 0.71 to the first, plus 3 choose 1 times 0.29 to the first times 0.71 to the second. You add those two probabilities up. I'm going to leave it to you to plug that in on your calculator. This is going to be about 0.7965. Now, Pascal's triangle, you've probably seen this before, and you probably know how to construct the next layer. You construct the next layer of the triangle by adding the two numbers right above. We're always going to start with a 1, and then you add these two numbers. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and then it always ends with a 1. There's always a 1 on either side. All right, so we can do as many levels as we want. 1, 7, 21, 35, 35, 21, 7, 1. 1, 8, 28, 56, 70, 56, 28, 8, 1. Fine, one more. 1, 9, 36, 84, 126, 126, 84, 36, 9, 1. Okay. So that's how you make it, but you probably didn't realize how many different applications it has to probability and stuff. Okay. So you can use Pascal's triangle to do a whole bunch of combinations. All right. I would rather use a calculator, honestly, because I don't want to have to rebuild this triangle every time I've got a problem. But 4 choose 2 is in the triangle. You have to, how you do it is this. If I want to do 4 choose 2, go to the 4th level of the triangle, which is right here. And basically, this is 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. You have to start at 0 and end at 4. But 4 choose 2 is 6. And so if I did 5 choose 3, you go to the 5th level, and 0, 1, 2, 3, 5 choose 3 is 10. 6 choose 3. Go to the 6th level, 0, 1, 2, 3. 6 choose 3 is 20. Okay, I'm going to double check that. 6 choose 3 should be 20. Okay, there we go. 7 choose 5. Anybody? Seven choose 5. It's 21. I think it's kind of neat how Pascal's triangle fits into our probability and combinations and stuff. Okay. Number 5, if each member of a 9-person jury acts independently of each other and makes the correct determination of guilt or innocence with probability 0.65, find the probability that the majority of jurors will reach a correct verdict. So I can see 9 persons, so that means n equals 9, and I can see the probability over here. Probability is 0.65. But what you have to pay attention to is language like this. Majority. You guys know what majority means? More than half. So be hyper literal. When they say majority, what do they mean? 5 or 6 or 7 or 8 or 9. So we have to add all these things up. Okay, 5 or 6 or 7 or 8 or 9. Okay, so really once you get the pattern, it's just busy work pretty much. So we want 5 of them, 5 of the jurors. So we'd say 9 choose 5 and 5 of the 65s. And what's the probability that they don't do whatever this is? 0.35, and there'd be 4 of them because it has to add up to 9. 5 plus 4 is 9. Or means plus. Now we do 6 of them. 9 choose 6. And we've got 6 of those things and 3 of the others. Or means plus. 9 choose 7. 65 to the 7th, 35 to the 2nd. Or means plus. 9 choose 8. 0.65 to the 8th, 0.35 to the 1st, or means plus. 9 choose 9, 0.65 to the 9th, 0.35 to the 0. So you have to add all that up. Add all that up. Well, I'm not going to type all that in. I think you've seen me do it enough that you know we're going to type that in plus, type that in plus, add all that stuff up. And in this case, it's going to add up to 0.8283.